Assalamualaikum and hi everyone. So I'm going to continue to discuss the last few examples in subtopic 2.3. Okay, let's look at example 17. A football is kicked at an angle 37 degree with a velocity of 20 meter per second as shown in figure here. So we are given the figure here. And then we need to calculate a few things. First, the maximum height. Second, the time of travel before the football hits the ground. The third one is how far away it hits the ground. Next one, velocity vector at maximum height. And the acceleration vector at maximum height. Okay, so first, let's highlight here. We have the angle 37 degree. And the initial velocity of 20 meter per second. Okay, as you can see here, so this is the initial point of the football. So this football is kicked at an angle 37 degree with velocity of 20 meter per second. Maksudnya initial velocity dia adalah 20 meter per second. And then after the football is kicked, it goes all the way up and then goes back to this point here on the ground, okay, which is point P dekat sini. Okay, so first let's write down the information. We have value for U 20 meter per second and then angle 37 degree. Okay, so first, what is the maximum height, which is the value here, which is also the same thing as the displacement at Y component. Benda yang sama. Okay, displacement at Y component. Okay, since we don't use the label H in our formula. Sebab dalam formula dekat sini, we have SY instead of H. Okay, so when we're talking about maximum height, okay, the important information that we know at maximum height, okay, we know that the velocity at Y component is equal to 0 and the velocity at X component is equal to the initial velocity at X component. Okay, so ni information yang penting apabila kita bercakap tentang maximum height. Always remember at maximum Vy kosong Vx sama dengan Ux. Okay, Ux ni daripada mana kita dapat? Okay, since we are given here the initial value, which is the value for U, we need to resolve into two components. So we have Ux here and then Uy here. So we need to find this Uy and Ux first. How to find this? It's easy. You just use the formula. Ux is equal to U cos theta and Uy is equal to U sin theta. So we are given the magnitude and the direction. So just masukkan sahaja 20 cos 37, which is equal to 15.97 meter per second, and then 20 sin 37 equal to 12.04 meter per second. Okay, so soalan A, we want to find SY. Okay, benda yang sama SY dan the value, the height is the same thing. Okay, so if we look at the formula here, since we want to find SY, so which formula do we have SY? It's either this formula or this formula. Okay, so we need to look at the information given first. Okay, untuk gunakan formula ni, if we want to use this formula, we need to have the value for T, which we don't have the value for T, so we cannot use this formula. Or you need to find the value for T first. But since we have this formula that doesn't require the value for T, we can directly use this one here. So let's write that down. Vy square is equal to Uy square minus 2g Sy. And we want to find Sy. And we know that here Vy is equal to 0. And then Uy, we have the value here. So just masukkan 0 is equal to 12.04. Don't forget the squared. Minus 2g. G is just the value for the velocity. And sy. Sorry, bukan velocity. Value for gravity. And then sy. So sy is equal to 7.39 meter. Okay, so that's the first one. Okay, next one, we want to find the time of travel before the football hits the ground. So maksudnya, okay, the time of the whole journey daripada this point all the way to this point, sampailah bola tu jatuh semula ke bawah, ke point P. Okay, so maksudnya dekat sini, the whole journey here, okay, the football actually is back to the origin. Dia kembali semula ke origin, which is sama level dengan initial point dia, level yang sama. So if it's the same level, you need to remember that, okay, the y displacement, okay, this maksudnya displacement at y component, sy. Sy, kalau dia sudah sampai dekat sini, sy akan jadi sama dengan, at here, sy akan jadi sama dengan kosong. Sebab kenapa? Sebab dia adalah y component. We want to find the y component. So kalau dia ngam-ngam dekat sini, we don't have the value for y component. We only have the value for x component. Ni adalah x. So y component dia adalah macam ni kan. But actually, dia adalah refer kepada initial point. So we don't have that y component. So y component dekat origin, dekat sini, adalah sama dengan kosong. So meaning that, we want to find t, right? So meaning that here, you either use this one or this one. Okay, you either use this one or this one. Either way you can use, should be able to get the t. But now I want to use this value here. This equation here. Sy is equal to uyt minus half gt square. Di mana sy akan jadi sama dengan kosong. Uy still the same thing, 12.04. T half g t square. So you will get the value for t is equal to 2.45 second. Okay, next one, we want to find how far away it hits the ground. Okay, how far away maksudnya, daripada point initial, berapa jauh dia jatuh ke point P ni. Maksudnya, ni adalah initial kan, daripada initial point. So, berapa jarak daripada point yang asal ke point di mana bola ni jatuh, which is actually the value for Sx. Okay, x component of the displacement, ataupun usually kita akan panggil dia sebagai range. So R here stands for range. So if the question asks what is the range, it's basically the same thing as Sx. So basically we want to find Sx, and then the formula for Sx. So this one you refer back to the formula that I given you in the previous GM. So Sx is equal to uxt, because the value for A is 0 untuk 4x component. Okay, original formula dia adalah this one. But since untuk x component, this one adalah kosong, so we left with this one. So just ubah kepada x component saja. You need to always label adakah ada x component ataupun y component. So this one is easy, di mana ux is still the same, it's not gonna change. And then t adalah time for the whole journey. Okay, time for the whole journey all the way to here, which is we have calculated this one. So just masukkan 2.45, then you will get Sx is equal to 39.13 meter. Don't forget the unit. Okay. Next one, calculate the velocity vector at maximum height. So at maximum height, which is dekat point ni, we want to find what is the velocity. Okay, apa maksud velocity vector ni? Bermaksud adalah we want to find the direction and also the magnitude. Sebab dia bagi tahu velocity vector. So you need to find direction and also magnitude here. Okay, but actually we already said earlier. We know that dekat maximum height, y component adalah kosong, x component adalah sama dengan initial x component. So you don't need to calculate that one, you just set again. Sorry, so this one is supposed to be D. So this one is C. Now is question D. So Vy, we know is equal to 0. And Vx, we know is equal to Ux, which is 15.97 meter per second. So this one, if you calculate the magnitude, we know that in order to calculate the magnitude, we need to use this formula, Vx square plus Vy square. But since kat sini adalah kosong, so basically it's the same thing, which is 15.97 meter per second. And what is the direction here? Okay, so we know that direction we need to calculate the angle. But you don't have to calculate the angle here. Because why? Because dia sudah cakap dekat sini Vy adalah kosong. Bermaksud dekat sini Vx sama dengan Ux. And then here is Vy. Bermaksud dekat sini the angle adalah sama dengan kosong. So angle sama dengan kosong, the direction is to the right. So you just set direction to the right. Sebab kenapa to the right? Bola tu kan dia macam ni kan? It goes from here to here. So obviously direction dia adalah ke kanan macam ni. And then bola dia jatuh ke bawah. So angle here is actually 0. So apabila angle kosong, automatic dia adalah just to the right. You don't have to set the angle. Okay? Jangan letak angle kosong lah. You just set always to the right. Okay? Okay, and last one, we need to calculate the acceleration vector at maximum height. So this one is easy as well. At maximum height, we need to find the acceleration. This one is basically ada sudah dekat dalam nota kamu, dalam table yang Miss buat sebelum ni semasa GM. So dekat maximum height, at maximum height, acceleration adalah sama dengan negative G. Maksudnya acceleration dekat Y component ke bawah. Acceleration at Y component dan acceleration at X component adalah kosong. Dekat X component here, we don't have acceleration. Sebab acceleration, sebab kenapa? Velocity constant. Okay, kita tengok semula dekat this one here. Okay, dekat horizontal, which is X component, velocity sentiasa constant. So acceleration adalah kosong. Dekat vertical ataupun Y component, okay, dia adalah constant gravitational acceleration, which is Y component akan sama dengan negative value for the gravity. So negative 9.81 meter per second squared. So this one is the same in any case. Okay, dekat maximum height, dekat any case, if you want to find it here, acceleration sama juga. Okay, so apa yang kita perlu buat, you just set it like this. So Y component is equal to negative 9.81 meter per second squared. And then X component is equal to 0. So the direction here, so you can say the acceleration is 9.81 meter per second square. Okay, don't forget the negative. And the direction, since it is negative, it is going downward. Okay, always set the magnitude. Ni adalah magnitude. Okay, ni adalah Y component, X component. And then you need to find the magnitude and the direction. Okay, boleh? Okay, so that's all for example 17.